is Prithvi Shanath and I am the TA for this course, Engineering Mechanics. I am a PhD student in the Department of Aerospace Engineering at IIT Madras. So this is week 7 for this course. So we will solve some questions. I suggest that you try solving them along with me. So the first problem, the block weighing W is being lifted by the lifting wedge as shown. During the analysis for the applied force P required for lifting operation, the state of motion of the lifting wedge relative to the floor is impending. It is true. Now the next problem. The horizontal and vertical motions of an object are independent of each other only when acceleration exists in the vertical direction. And the reason for this, a projectile can have any initial velocity, but the acceleration is always the free fall acceleration g. So can you tell me which option is correct for this question? In assertion, it is mentioned that horizontal and vertical motions are independent only when the acceleration exists in the vertical direction. So is this true? So this assert A is false. And for reason, a projectile can have initial velocity, but the acceleration is always the free fall acceleration. This is true, right? Only g exists. So A is false, but R is true. Is there any doubt in this problem? Okay, so we will solve the next problem then. Consider the system of frictionless pulleys connected as shown to a lift of a weight W. The mechanical advantage obtained using this arrangement is, you need to find the mechanical advantage of this system. So can you try working out this problem? There are 4 pulleys. You need to find the mechanical advantage of the system. So did you get the answer to this question? So for pulley A, the weight is acting downwards, and suppose this is T1 and this is T1. So 2T1 equals to W, T1 equals to W by 2. This is for pulley A. For pulley B, suppose this is T2, and this is W by 2 as calculated. So 2T2 equals to W by 2, T2 equals to W by 4. Now for pulley C, if this is T3, this is W by 4. So 2T3 equals to W by 4. Therefore T3 equals to W by 8. Therefore P equals to W by 8. Now to calculate the mechanical advantage, it is given by the formula W by P. So W and P is W by 8. We already calculated this. So mechanical advantage is 8. Is there any doubt regarding this problem? You can tell me if you have a doubt. So moving on to the next problem. Two balls are thrown simultaneously with initial horizontal velocities u1 and u2 from two floor of a lighthouse as shown. Considering gravity acting in plus y direction and ignoring the effect of air resistance, answer the following questions for h2 by h1 equals to 2. How many times longer will ball 2 take to reach the ground as compared to ball 1? Can you try solving this problem? So did you get the answer for the first part? So it is given in the question h2 by h1 equals to 2. So for case 1, h1 equals to u1t plus half gt square. So in the y direction, the velocity is 0, right? So this will be 0. h1 equals to half gt square therefore t1 equals to under root of 2h1 divided by g. And for case 2, similarly, h2 equals to half gt. For this also, the initial velocity in the y direction is 0. So t2 equals to 2h2 by g. Therefore, we need to find the ratio, right? So we need to find T2 by T1, that is 2H2 by G therefore T2 by T1 equals to, we already know this ratio, H2 by H1 is 2. So this is 1.41 seconds. Are the steps clear? Is there any doubt for this? So for the next part, now in this part U2 is given as 7 meter per second. So what should be the velocity of ball 1 in meter per second such that both the balls hit the same point on the ground? We need to find U1 such that the balls hit the same point on the ground. First you can try solving this. So suppose both the balls hit the ground here. So basically this distance traveled by both the balls should be same, right? Both the balls should meet at the same point such that we need to find the velocity such that both the balls meet at the same point on the ground. So the distance traveled by ball 1 it is given as U1 T1, and this is in the x direction, right? So there is no acceleration in the x direction, so we can simply write it like this. Now distance traveled by ball 2 is U2 T2. Now what is the condition? Both the distance should be same. So I can write this as u1 t1 equal to u2 t2. So I need to find u1 from this condition, right? We know u2, we know the ratio of t2 by we know already the ratio of t2 by t1. So we just need to substitute. This is u2. We already found the ratio of time as 1.41. So this becomes 9.87. Now the next part of the problem. Let h1 be 3 meter, and if the ball 2 is released vertically instead. Now initially what we saw that both of these balls have a horizontal velocity. Now it is mentioned that ball 2 is released vertically instead. So how long in seconds after its released must ball 1 be shot horizontally such that both the balls simultaneously reach the ground? Ball 1 is shot horizontally as shown in the problem, but here ball 2 is released vertically instead of horizontally. So you need to solve that. So it is given that h1 equals to 3 meter So from there, what can I write? We already know h2 by h1 is 6, right? Sorry, 2. h2 by h1 is 2. So what is h2? h2 is 6 meter. So from this we can calculate the time required for ball to reach the ground, right? So time required by ball 2 so it is already mentioned that it is released vertically, so this will be 0 and h2 will be 6 into half gt square, therefore t will be 12 by g. So so this will be 12 by, which is 1.11. Similarly, we need to find the time required by ball 1 to reach the ground, right? So there is no velocity in the vertical direction, so this is h1. h1 is given as 3, right? So this is so this is 1.35. This is 3 into 2, not 6. So this is 0.787. So the difference in the time will tell me, like after how much time, how long after ball 2's release should ball 1 be shot. So the difference in time will give me that. Therefore, that is 0.33 seconds. Is there any doubt regarding this problem? You can tell me if you have any doubt. Is there any doubt? Am I audible? Okay, so we'll move on to the next problem. A centrally pivoted disc rotates in the clockwise direction initially. A massless inextensible brake band wraps around the rotating disc in order to bring the disc to a halt. The brake band is applied with a braking force P at one end and is clamped at the other end as shown. Answer the questions based on the given data. Which is true about the frictional force applied on the brake band due to braking action? So can you tell me which option is correct? So the disc is rotating in a clockwise direction. So the friction should act on the disc in this direction, right? And on the belt, like on the band, it should act in which direction? This direction, right? This is on the band. So which is true about the frictional force applied on the brake band? So we can see that it is in the clockwise direction, right? Is there any doubt regarding this? So the next part, which is true about the frictional force applied on the disc due to the braking action. Now we need to specify the direction on the disc. So we already found it out, which is anti-clockwise in direction, right? Therefore, it is anti-clockwise in direction. Now the next part, given that the tension in the brake band segment AB is 500 Newton, when the brake is engaged, what is the magnitude of tension in Newton in segment CD? So this is AB, this part is AB and this part is CD. We are given tension in the AB segment, which is 500. We are asked to find out the tension in this CD segment. So can you tell me which one is T1 and which one is T2? So this is T2 and this is T1. Therefore, we can just write the formula T2 by T1 equals to E into mu theta. Mu is given as 0.1 and T1 is 500 Newton. Therefore, T2 is, and theta is pi, right? You can see from this figure, and it should be in radians. So zero point 0.1 into pi, which is 684.55 Newton. So this is the answer. Is there any doubt regarding this problem? You can tell me if you have any doubt. So the next problem. A boat speeds up while traveling along a path as shown. The boat is being monitored from a lighthouse L. The total radial distance of the boat from the lighthouse is increasing constantly at 12 meters per second. At the instant when theta equals to 45 degree, it is found that the boat is at radial distance of 600 meter from the lighthouse with theta dot is equal to 0.3 radian per second and theta double dot equal to 0.1 radian per second square respectively. Answer the following questions for the instant depicted based on the given data. So here you just need to substitute values in the formula. Can you try solving this question? So the first question is, let RB represent the position vector of the boat with respect to the lighthouse L. The ER component of RB is. So it's a simple question, you just need to substitute values in the formula. So it is given that RB is the position vector of the boat with respect to the lighthouse, right? And it is also mentioned that the boat is at a radial distance of 600 meters. So RB is basically 600. So ER component now it is asked for the E theta component. So there is no E theta component. So the E theta component of RB is 0. Now the next part, let V represent the absolute instantaneous velocity of the boat in meter per second. The ER component of velocity is. So what are the data that we know? And we know velocity is given as R dot R theta dot E theta. Now we know that from the given question, R dot is given as 12 meter per second, right? Theta is 45 degree. R is 600 and theta dot is 0.3 radians per second. So I just need to substitute these into the equation. So we are asked to find the ER component of V. ER is nothing but ER component is nothing but 12. So the ER component of V is 12 meters per second. E theta component. So E theta component is 180. Now for the next part, let A represent the absolute instantaneous acceleration of the boat in meter per second square. The ER component of A is it is almost similar like the previous problem. You just need to write the formula for acceleration and then substitute the values, and you already know the data given in the problem, so you can easily find it out. So can you try doing it? So, did you get the answer? So, we know that A is given by so R double dot is 0. It's now R is given as 600 and theta dot is 0.3, right? What is theta double dot? Theta double dot is given as 0.1 radians per second square. R dot is 12 and theta dot is 0.3. Yeah, 0.3. So this is E theta. This is coming out to be minus 54 and this is $67.2. Sorry, there won't be a square here. So the E theta component is E theta component and the ER component minus 54. So is the angular velocity of the boat is same as theta dot. This is false. And can the boat be treated as a particle? Yes, it can be. So this is true. The boat can be treated as a particle for this problem. So this week we've solved these problems. So the last part of the problem is the angular velocity of the boat is same as that of theta naught. So it is false, right? And the boat can be treated as a particle for this problem. It's true. The boat can be treated as a particle for this particular problem. So for this week, we discussed. So the first problem was during the analysis of the applied force P, the state of motion of the lifting wedge relative to the floor is impending. So this is true. And the second question is also simple. In the third problem, we had to find the mechanical advantage. So for the first pulley A, we assume the tension to be T1. So T1 comes out to be W by 2, and for pulley B, we assume that the tension in the rope is T2, and this is supporting W by 2 weight. So T2 from there we get as W by 4. Similarly for pulley C, we get T3 as W by 8. So mechanical advantage is given as W by P. So we found out P to be W by 8. So from there we get mechanical advantage to be 8. Now for the next part of the problem, two balls are thrown simultaneously with initial horizontal velocities u1 and u2 from two floors of a lighthouse, and the ratio of the two height is also given, which is 2. So how many times longer the ball 2 will take to reach the ground as compared to ball 1? Basically we need to find out the ratio of the times. So this is for the y direction. So in y direction we have no velocity, so that is 0. Therefore time is given by this expression. It is same for both the cases, only the height is differing. So finally we need to find the ratio of T2 and T1. We substitute and get it as 1.41 second. Now for the second part of the problem, u2 is given as 7 meter per second. We should find the velocity of ball 1 such that both the ball hit the same point on the ground. That means this distance should be equal. So since there is no acceleration in the x direction, we can directly write as u1 t1, and for ball 2 it is u2 t2. and we know that both the distances are same. As per the given condition, it should be same. So from there we get velocity of the ball b1. Now for the third part of the problem, h1 is given, so from there we can find h2, which is twice of h1, so that is 6 meters. Now we can find out, instead of throwing it horizontally, the ball 2 was released vertically. So the initial velocity is 0. From there I get my time, get the time as 1.11 seconds, and same with ball 1, but this ball 1 is shot horizontally, but what happens is the vertical velocity is 0. So again we compute time as 0.8 seconds. From there we find out the difference in time. So after, if we shot the ball 1 after 0.33 seconds, both the balls will reach the ground simultaneously. Now for the next problem, we were it is a disc is given, which is centrally pivoted, and a brake band is wrapped around it. We are asked that which is true about the frictional force applied on the brake band. So the disc is rotating in a clockwise direction. And the brake band is applied so that the disc is brought to a halt, right? So the friction will act in the opposite direction on the disc. So the friction is in the anti-clockwise direction on the disc. Similarly, it's clockwise on the belt. So for the first part, what is true about the frictional force applied on the brake band? Brake band, we can see from the figure that it should be on the in the clockwise direction. Similarly, which is true about the force applied on the disc? Frictional force applied on the disc, it should be in the anti-clockwise direction. And in the final part of the problem, we need to find the tension in the segment CD, which is T2 for this problem. So we just simply substitute the values and get T2 as 684.55 Newton. And for the next part of the next problem, a boat is given which is traveling with a radial distance, which is at a radial distance of 600 meter, and the radial distance of the boat from the lighthouse is increasing constantly at 12 meter per second. And other data with theta dot is 0.3 and theta double dot is 0.1 radian per second square. So we need to find the ER component of RB. RB is given as the position vector. So the ER component of RB is 600 meter. And the theta component, E theta component is 0. Now we are asked to find out the components of velocity that the boat has. So this is the formula to find out velocity. Now we are given all this data, r dot, r theta dot. So we just simply substitute, and the component of ER is 12 and component of E theta is 180. Similarly, we need to solve for acceleration. R double dot is 0. So by substituting all the values, we get acceleration component in ER component of acceleration is minus 54 and E theta component is 67.2, and the angular velocity of boat is not as same as that of theta dot. The boat can be treated as a particle for this problem. It is true. So is there any doubt regarding this problem, all these problems that we solved this week? You can tell me if you have any doubts. Okay, then we can stop here.